Okay, so ignore that sound. Good morning, guys.
Good
Good
morning.
morning.
Good morning.
Morning.
Good morning.
Good morning. Okay, so let me share screen here and then we will start today's classes. You guys can see my screen, right? Okay.
Yep.
Okay. So, okay, good morning, guys. And today we will study the properties of functions. And yeah, hope you guys enjoy the class. And then first we will introduce 7 different types of symmetry. And it has point symmetry, line symmetry, origin, x-axis, y-axis, and y equal to x and y equal to negative x symmetry. So yeah. Yeah, Nicholas, go ahead.
Okay. Yeah, so our first symmetry is called point symmetry. Point symmetry is when every part has a matching, every part of the shape or graph has a matching part the same distance from the central point, but in the opposite direction. So as you can see in this graph, you have a star in the first quadrant in the top right. And so it has a point symmetry with a star on the bottom left, where the point is the origin. So the point is the middle of those two lines. So every part of the star has a matching part the same distance from that origin, but in the opposite direction. And so the result is the star in the bottom. So that is point symmetry.
Alex, go ahead.
All right, okay. I guess I'll go over line symmetry. So basically, as the slide says, the line of symmetry can be defined as the axis or imaginary line that passes through the center of the shape or object and divides it into two identical halves. So let me just annotate real quick to show you the line of symmetry over here. For example, in this specific graph, the line of symmetry is just the y-axis because this parabola-shaped graph has its minimum point at the origin. So we know that the y-axis is its axis of symmetry because each portion, if we split it, is equal to each other, right? So that's basically the definition of symmetry, that you can split it into two halves in order to be identical in each half. As we can see, this point has exactly the same distance from the y-axis as this point, and this point has the exact same distance from the y-axis as this point. So that's basically line symmetry.
Jasmine? Are you there? Okay, Nicholas, go.
Oh yeah. So this next origin symmetry is very similar to what I talked about a couple seconds ago about point symmetry. So origin symmetry is a special case of point symmetry. So as we all know, the origin is the point 0, comma 0. It's the point in the middle of the of the XY graph. So an easy way for to see origin symmetry is if you reflect the original graph or line or shape by the x-axis, and then you reflect it again over the y-axis, the resulting shape and the original shape makes an original symmetry. In other words, this is a point symmetry, right, where the point is the origin. And another way to think about this is an origin symmetry is rotate the shape by 180 degrees. Yeah, so in the top left, you can see that curved graph. If you rotate it about the origin by 180 degrees. So if you just rotate that 180 degrees, then you'll see that it has origin symmetry because it's the same thing.
All right, so another form of symmetry is called the x-axis symmetry. And from what we can see here down in this figure below, we can see that this graph over here, this sideways V-shaped graph, is perfectly symmetrical along the x-axis, which means that the x-axis perfectly splits the graph into two corresponding parts. For example, xy has the same distance to the x-axis as x minus y, and minus xy has the same distance to the x-axis as minus x minus y. So this occurs if the y-coordinate is replaced with the negative y-coordinate, and the resulting equation yields the original equation. So this is basically the x-axis symmetry in a nutshell.
All right, I can take this one as well. So y-axis symmetry is very similar. It's almost the same to x-axis symmetry, but just with the y-axis, with the vertical one. So a graph will have symmetry about the y-axis if we have an equivalent, an equal equation when all the x's are replaced with negative x. So if you have a function f of x, if you put in negative x into that function, so if you have f of negative x, then you will get the same result as if you put in f of x. So as you can see in this graph, which is y-axis symmetrical, the value for negative x is y, and the value of the graph when you plug in x is also y. And so that's when you have y-axis symmetry.
Okay, so y equal x symmetry is about the line y equals x. And this happen if only for the point AB, and it's the first first graph exactly when the point B over A, just like the graph on the left. So you guys can see. And if you need to take notes, please go ahead and do that as well.
All right, I guess I can go over this slide. One thing that I wanted to add about the y equals x symmetry is that any reflection over the line of y equals x represents the inverse of that function. So basically, any value you plug into the original function gives you the input of the inverse function. You can think of it like that, like the reflected graph across the line of y equals x basically returns the value that you plug in into the original function. Now, for y equals negative x symmetry, it is very similar to y equals x symmetry, except it's just the opposite direction. You reflect over the y equals negative x equation instead of y equals x. So it's just symmetry about the line of y equals negative x. And that's basically about it. Here, I'll draw like a line over here to like just represent it's just reflected over this line over here. So that's basically y equals negative x symmetry, in case you needed like a visualization.
Harry, go ahead.
So the odd function that we said before of origin symmetry is a special case. So this is also a special case function. Odd function is a type of function which satisfies that the function itself is a central symmetric figure and its center is exactly the origin 0, 0. Simple method to identify odd function. When we see an x to the nth power type function, if the absolute value of n is an odd number, then its function is an odd function.
All right, so some key tips about odd functions. The definition for the odd function can be represented by that equation at the top left. F of negative x equals negative of f of x. So if you have a function f of x that makes that equation true for all values of x, then it is an odd function. Similarly, if you move around the variables there, you have the transformation, which is f of x divided by f of negative x is equal to -1. Now, so not only the graph, but also the domain must be origin symmetric. For example, um, yeah, basically, um, yeah, so all values of x, so all for all values of x, the function value of negative x should produce the negative y. So you should have a point like x comma y, and then if it's odd, it should also have the point negative x comma negative y. Um, and it's okay if the domain does not include 0. It does not include x equals 0. But but if x equals 0 is in the domain, the point must be 0 comma 0. Here, yeah, we had a couple examples on that slide. But you could just take a look. Now we'll go into some practice.
Okay, I will go back to this slides if you guys need for take notes. And yeah, you can screenshot the slides, and if you need it, we can send the slides link to you guys as well. Yeah, so here are some practice about you guys can define like which type of symmetry is this, and then after like you got your answer, you can type it in the chat box or you can say it out loud. And we will give you guys about 1 minute to do that. And yeah, feel free to type your answer. Okay, so what about Alex? You can go over those two with them, and then we can, yeah.
All right. Okay. So I think it's already like marked on the graphs like like the symmetrical portions of each graph. Like for example, here in the first figure, we can see that the figure is symmetrical about the y-axis. Sorry, that's not a straight line. It's symmetrical about the y-axis, and thus any corresponding value, any corresponding y value over here is also apparent over here, right? Now, for this second figure over here, it's about the x-axis. So this is x-axis symmetry because for every single x value that you have another corresponding x value, but with a negative y value. So that's how you know if a specific graph is y-axis or x-axis symmetry.
All right, so we have a couple more practices here. So if you can look at these two graphs, Okay, and find which types of symmetry these two are. We'll give you a minute to do that, and then we'll explain what the answers are.
Yeah, and does someone has questions? Do you guys have any questions? If you
No.
okay, if you do, please like don't shy to say it out loud.
I think it's point symmetry, I think.
Okay, you think it's a point symmetry?
Yes.
Okay. I got few answer here. And what do you guys think for the second one?
Second one is line symmetry.
Line symmetry, okay. Okay. Cool, very nice. Nicholas, do you wanna go over the answer?
Yeah, sure. So yeah, you guys got it mostly right. So the first one on the left is a point symmetry. If you want to be more specific, it is also it's also an origin symmetry, because that point is the origin. So this is the special case of original symmetry. You can see that because that weird squiggle shape in the top right, if you rotate it 180 degrees, you get the bottom left shape. So on the for the graph on the right, it is a line symmetry, but you can also be more specific. You can say it is an x-axis symmetry because the line that it's symmetric about is the x-axis. So the x-axis symmetry is a type of line symmetry. So line symmetry would be correct, but to be more specific, yeah, the line of reflection is the x-axis.
Yeah, good job, everyone. Yeah. So, yeah, I think for this one, you just need to find the line of symmetry. So maybe Alex, do you want to show an example of how to do it for the first one only?
All right, okay, I guess I'll go over the first one. So a good little tip while trying to find the line of symmetry is you can take the distance between two corresponding points and then find the mean of that. And what I mean by the mean is you divide it by 2 since there's only 2 points, right? So for example, the distance between A and A prime is 6. So 6 divided by 2 is 3, which means the line of symmetry is 3 units away from point A. Now let's look at point W and W prime. The distance between W and W prime is exactly 8 units, right? So 8 divided by 2 is 4. So that means our line of symmetry is exactly 4 units away from W, right? So judging from this, we can see that the line of symmetry is the x-axis. And that is because the x-axis is the only line on here that is exactly 3 units away from the A point and the A prime point and 4 units away from the W and W prime point. And if we test it out with D, we also see that it's exactly this is 5. That it's exactly 5 units away from the line of symmetry. So this is how you would do it. You can apply it to other shapes as well, but under some circumstances, this could become harder to do as you encounter irrational numbers, as you would see in figure 2. I'll give you some time to figure it out.
After you're done, you are free to type your answer in the chat, or you guys know it, you can also say it out loud.
First one is and
Oh, can you repeat that again? Yeah, can you say it one more time?
first one is line segment.
Which line segment again?
Thoughts.
What can you like say it one more time? Or you can also
First one is
yeah. You can type your questions or answer in the chat. So you guys can find the equation of the line. That's what Alex said. But you guys did like the first step for right? So okay, so what about Alex? Alex, you can just you know, explain the answers.
You want me to go over one again, or do you want me to go over two?
2.
All right, okay. So if we try to apply the same methodology that we used for the first diagram, it wouldn't work very well, as we can see. This is not like a very easy to comprehend number. Although if you do know Pythagorean theorem, you would know that this line segment is square root of 2 units and this line segment is square root of 8 units, but that's too messy for us. So instead, we try to look for like a common trend along these like points. And basically, if we find that trend, we find that the line of symmetry is just this diagonal line over here. Now, if you recall correctly, this line over here is also just the graph of the equation y equals negative x. So these diagrams over here would be symmetrical via y equals negative x symmetry. You just have to find like the line where each corresponding point is the same distance away as their corresponding points.
Okay, so do you guys understand? Or do you guys have any questions? Yeah or no?
Sorry, I don't understand.
All right, I guess I can go over that one more time. So basically, the line of symmetry is just a line in which two corresponding points from the both of the figures have like the exact same distance too. For example, over here, we can see that from A to the line of y equals negative x is a distance of square root 2 units, right? Because of the Pythagorean theorem, 1 plus 1 equals 2. Square root of 2 is this distance right over here. Now, if we apply the same logic to this point, A prime over here, we also find that the point is equidistant to the line of symmetry because 1 squared plus 1 squared is 2, so square root of 2. Now because that we know the two points have equal distances to the line, we can deduce that this is the line of symmetry right over here because each point has a corresponding point that has the equal distance to the line.
Yeah. So do you guys have any questions about it? No? Okay. Okay, so I think that's it for today. We can continue for next time, or we can figure out some other fun unit for you guys. And yeah, okay.
Bye
So-
bye, everyone.
Yeah, okay. So if you don't have any question, you can leave for today. And thank you guys. Yeah, and yeah, Harry and maybe Nicholas, you guys, I need to talk to you guys. But yeah, other than that, you guys are free to leave. Thank you guys. Okay, well, Alex, maybe I will talk to you also. Okay, so what about Harry, Nicholas, and Alex? I will just end the meeting right now, and can you guys rejoin my Zoom? Because, you know.
All right, sure.
Yeah,
I'll do that.
thank you.